All right, let's get into it. Today we're cracking open Chapter 10, Data Analysis, Tools for Describing Data, from the book Research Methods for the Real World. The whole point here is to break down how you take a giant, messy pile of numbers and actually turn it into a story that makes sense.
Oh yeah, this moment, we've all been there, right? You're just staring at this wall of raw data, a total sea of numbers, and it means absolutely nothing, yet. You can feel super intimidating, but trust me, this is where the fun starts. This is where you begin to pull the story out of the chaos.
Okay, so first things first, you have to know what kind of data you're actually looking at. And look, this isn't just some boring academic bullshit you can skip. This one step determines literally everything you're allowed to do next. It really is like the sorting hat for your data. You gotta know which house your numbers belong to before you can play any games.
So you've got these 4 basic levels, these 4 food groups for data, and they kind of build on each other, like you're leveling up in a video game. Each level up unlocks a new power, a new move you can do. We go from just slapping names on things, to putting them in order, to knowing the exact space between them, and finally, getting to a true zero. It's a ladder of precision.
All right, first up, nominal. Seriously, don't let the fancy name trip you up. It's literally just putting stuff in boxes. That's it. You've got sedans, you've got trucks. You've got brown hair, you've got blonde hair. One isn't more or better than the other, they're just different buckets. No order, no ranking, just labels.
Okay, so moving up the ladder, we get to ordinal. Now we actually have an order to things. We know that first place is better than second place. But here's the catch. You don't know if they won by a tiny fraction of a second or by half a damn lap. The gaps between the ranks? Total mystery. All you know is the order.
Now things are getting interesting. With interval data, the steps are finally equal. The distance between 10 and 20 degrees is the exact same as the distance between 70 and 80 degrees. The spacing is consistent. But, and this is the thing you got to remember, 0 doesn't mean nothing. 0 degrees Fahrenheit doesn't mean a total absence of heat, right? It's just another point on the scale. The 0 is arbitrary.
And finally, we reach the top of the mountain, ratio data. This is the top tier. It's got the equal intervals we just talked about, plus a true meaningful zero. Zero height is no height. $0 is no money. And this is the only level, the only one, where you can say something like, this is twice as heavy as that. It's the whole damn package.
All right, so you've done the hard work. You've sorted your data, you know what house it's in, awesome. Now it's time to turn that boring grid of numbers into a picture, something our brains can actually understand. For real, stop staring at the spreadsheet. It's time to actually see the story.
So you've got that nominal data, those categories, right? And it all adds up to 100%. Man, the pie chart is your go-to. It's so simple. Your eyes just go right to the biggest slice. Like here, with where grad students plan to work. And boom, you instantly see that school setting is the biggest piece of the pie. It's simple and it's super effective. Now this is where the story really starts to get juicy. A scatter plot lets you see if 2 different things are like dancing together. Each little dot on here, that's a person, and you can just see with your own eyes this clear pattern. As scores on test 1 go up, the scores on test 2 go up too. You're literally watching a relationship form right in front of you. It's not just random dots, it's an insight. And hey, don't get hung up on column graphs versus bar graphs. Seriously, one goes up, one goes sideways, who cares? The only thing that matters is this. You're comparing things side by side. It makes it super easy to see, say, how one group did compared to another. It's all about a quick, clean comparison. That's the job.
Okay, so we've seen the picture, but now we need to boil it all down to a couple of key numbers. We need to be able to answer 2 basic questions. What's the typical score, and how spread out is everything else? Think of it like this. What's the big headline, and then what's the important detail in the fine print?
So let's talk about the average. Most people immediately think of the mean. You just add everything up, divide by how many there are, easy. But, and this is a huge but, there's another player in the game, the median. That's the number that's physically in the middle if you line them all up. And this difference is crucial, because sometimes the mean is a complete liar. And hey, don't just take my word for it. The book lays it out perfectly. A couple of really wild, extreme scores, we call them outliers, they can completely wreck your mean. They can grab it by the collar and drag it way off center, giving you a totally bogus picture of what's really going on. Let me show you exactly what I mean. This is called a positive skew. Think about it like this. 10 people are in a bar, and their average income is 50 grand. Then a billionaire walks in. Suddenly, the mean income in that bar is
I don't know, $100 million bucks. The mean gets dragged way out to the right. But the median, the guy in the middle, he's still making 50 grand. The median tells you the real story.
And yeah, it works both ways. Here you've got a negative skew. A few really, really low scores can tank the mean, dragging it down into the gutter and making everything look way worse than it is for the typical person. And who's holding down the fort in the middle, totally unbothered? The median. It's the stable, trustworthy number.
So, knowing the middle isn't the whole story. You also need to know the spread. That's where standard deviation, or SD, comes in. It basically tells you, on average, how far away is each data point from the center. Are we all in a tight little huddle, or is everybody scattered all over the field? That's the story the SD tells you.
So why the hell did we just go through all that? Because this stuff isn't just for a stats class or some scientist in a lab coat. This is about being able to navigate the world without getting fooled by shady numbers. In the news, in that report for marketing, in a politician's speech. This is data self-defense.
So this is it. This is your basic toolkit. Know what kind of data you have. Make a picture of it first. Always question the average, and always be on the lookout for those outliers that bend the truth. This is how you go from a chaotic spreadsheet to an actual defensible insight. This is how you find the real story.
So here's what I want you to walk away with. The next time you see a statistic thrown at you on TV or online, don't just nod your head. Stop and ask the questions. Is that average the mean or the median? What's the spread look like? Are there a few crazy scores messing with the whole picture? You now know enough to be dangerous. You know how to find the real story behind the numbers.